Modern software builders are facing unprecedented challenges, such as end users wanting the services to be always online, product teams always wanting to roll out features faster and safer. In this session, we will talk about how to answer those questions through AWS Distributed Load Testing. Welcome to this session. My name is Miranda Lee, and I am a Solutions Architect from AWS. In the following 30 minutes, we'll follow a typical product lifecycle and talk about how performance testing and monitoring will help us answer key business questions. Then we'll look at some of the tooling in AWS that can help you to easily jumpstart your performance monitoring and testing. Finally, we will look at a simple pet store online shop that I have built and then use those tooling to help us understand the performance and potential bottleneck of this application. This is a 300-level talk, and I expect that you have basic knowledge of application monitoring and testing, and some of the AWS services such as CloudWatch and ECS. I will be providing the resources at the end of this session, which you can use to learn more about the technologies we just discussed. Let's start with the word confidence. When software grows with increased complexity and user numbers, engineers are afraid of making changes. They're afraid that changes might break the functionality or performance of the existing components. And they're also afraid of onboarding large number of new users. Well, if fear slows you down, then the confidence should speed you up. And automated testing and monitoring do just that. System performance is no different than any other features. In fact, it is the key ingredient that can distinguish market winners from the rest. We know that the faster we deliver the results, the more valuable people find our service. Imagine you would like to adopt a dog or cat. When you open that website, you end up staring at a blank page for several seconds while the site loads. What would you do? Most people would just close that page and search for an alternative. When the system is still small, the page loading problem is a performance issue. But if the system has to cater to a significant number of users, it quickly becomes a reliability issue. That's why performance monitoring and testing will help the engineering team accelerate with confidence. It's something worth spending time on. Now, let's imagine we're going to launch our own version of this pet store website and launch it as our hot new startup. There's a good chance that we'll have to walk the pet store through the whole product lifecycle. The project will start by designing, coding, and launching a minimum viable product, or MVP. Then, in the introduction phase, we'll post some adverts on bus stops and local TV channels to drive our first traffic. Then, if we're lucky, the pet store will experience rapid growth, and we'll be rushing to release new features. Eventually, our pet store will saturate the market, and we will need to continue innovating to keep expanding. During this whole life cycle, the CEO is going to ask us questions that's related to the performance. During the build and introduction phases, the product team's main task is to build and deliver the minimum viable product. At this point, the CEO is asking, how many people can log in and view the store at the same time? What will happen if we schedule the TV advertisement for next week? Is the site ready for all those challenges? After this phase, as part of the product team, your main responsibility is to keep the site stable. Whenever we have new visitors, we need to make sure the experience is good with snappy performance. All the while, we need to be adding new features that customers want. Your performance monitoring need to answer, what is our current baseline performance? Are our new features working as expected? What about old features? Is the site performing better or worse than our previous versions? And most importantly, where specifically is the performance bottleneck? We need a robust suite of performance testing and monitoring to let us answer all those questions. As the first kind of performance testing, load testing is the most basic and well-known. Let's say that in our pet store, we're hoping to get 500 users on day one. So we'll create a load test script and configure it to run 500 virtual users and run it for, let's say, an hour's duration. And after this load test completes, we can analyze the test result to determine how the application will behave under this level of load. At a later point in the demo, we will run this test together and try to answer our CEO's question: how many users can use the sites at the same time? Next, we have stress testing. This is actually to push the boundary and see how the site will perform. If our TV ads are successful and we get a lot more users than we expected, in this case, we will run a test with 700 virtual users and confirm that we have some headroom available to handle additional users without impacting the overall performance. Then next, we have spike testing. Sometimes a promotion can result in a dramatic increase in visitors in a very short period of time. We can perform spike testing before any promotion to make sure the system is able to scale quickly or is correctly pre-warmed before the event even begins. And finally, we have endurance testing or soak testing. This is where we test how our application performs under heavy load for an extended period of time. Features like analytics or reporting can sometimes put heavy load on the system. Incorrect code could also cause memory pressure to build up slowly. By running endurance tests for multiple days, we can be confident that our site is working and ready for any load we throw at it. But the question is, how can I generate such load? Let me introduce our very first toolkit, the AWS native distributed load testing solution. This solution is based on open source load testing tool, Apache JMeter. It also gives real-time metrics and information about how the application or the website is performing. This lets the developers to find performance bottlenecks and optimize applications accordingly. The solution makes it easy to distribute load across multiple AWS regions and simulate different network conditions. This makes it ideal for public-facing applications that need to perform for users from anywhere. We'll deploy the solution together just in a minute. But before that, let's take a closer look under the hood. The distributed load testing is built using AWS serverless technologies, so it's quite cheap and easy to operate. There are two main parts involved. First is the front-end interface. This lets you set up test configurations and then view the testing results. The backend, we have load generator, is where the application load would actually come from. When tests are run, JMeter tasks will be spun up in ECS Fargate to generate the load from your virtual users. When tests are complete, then all these tasks are cleaned away, so you only pay for the duration of your use. Getting started with this solution is pretty easy. Let's jump into my AWS account and have a look. Here, I am landed on the distributed load testing homepage. We'll find how to deploy the solution from here. Let's visit the documentation page to finish setting everything up. In here, we will need to click on the button View Implementation Guide. Upon click, we will be redirected to the documentation page, which contains lots of advanced configurations and workflows. I will put the link in the resource section just later on. But right now, let's focus on setting up the solution. What I will need to do is to navigate to automated deployments. Here is a big blue button that says Launch Solution. Let's click this. We see the CloudFormation dashboard, which will deploy the solution for us. Click on the Next. In here, let's give it a name, Pet Store Distributed Load Testing. And I will be the administrator. I will use my own email to receive the login information upon successful deployment. Leave the rest as it is. Let's submit the job for CloudFormation. This whole process will take roughly 20 minutes. Okay, now the deployment is finished. Upon its successful deployment, I have received an email about my login details. Let me bring this up. Let's use this information. I am required to reset the password when the first time I log in. Now that I have logged into the Distributed Load Testing dashboard, we'll see some historical testing reports from here. Then let's click on Create Test. Here's the place for us to create a brand new testing scripts. There are some setups we can do. You can run the load test against a single HTTP endpoint or a JMeter script, which can be generated using a local version of JMeter. If you have multi-region deployed, you can also see the region information here. We will be using this tool in a demo just in a minute. So, okay, this is how you set up the distributed load testing on AWS, which is pretty simple. Now that we have located and deployed the tool, AWS Distributed Load Testing, which can be used to answer the CTO's question, we will run the test together later on. Let's look at other questions from our CTO's list. Our pet store is open 24/7 and it's serving customers worldwide. Our next challenge is, how are we going to monitor it? We don't want to run the load test in production, but we want something to tell us if the application is working or not. Is there such solution? Can we have something to detect performance degradation a step ahead and be a little bit more proactive? Let me introduce synthetic testing or synthetic monitoring. This is a type of emulation that can replay recordings of a real user interactions to help you keep an eye on how well your software is actually running. You can think of it as a bot that sits here 24/7, clicking on all the pages, buttons, and testing your endpoints on your behalf, so it can alert you quickly if things start to go wrong. In AWS, we have a service for this, which is called CloudWatch Synthetics. CloudWatch Synthetics calls these scheduled synthetic tests canaries. You can configure canaries to follow the same action as an end user would do. For example, on our site, a canary could browse for products, add them to cart, and then complete the purchase flow. Those canaries can run 24/7 and will let us know quickly if any part stops working, or even it's working but it's starting to perform poorly. Synthetic testing helps us answer the questions of, are my features, both new and old, working and performing as we expected? Now that we are regularly running the load testing at scale before each new release, and we have synthetic testing running 24/7 in production to help us keep an eye on things, we are very well prepared to identify where is the performance issue. But once we have found one, how can we improve it? How do we look inside of our system to diagnose issues and identify those bottlenecks? Let me introduce AWS X-Ray, which will give you insights on which part of the system is or isn't working. Getting started with X-Ray is as easy as including the SDK into your application, or there are some auto-instrument agents available through the Open Telemetry project. There is existing support for almost all popular programming languages. Next, there is an X-Ray daemon. This component is responsible for shipping all the data that is emitted from the SDK back to the X-Ray backend. Then the X-Ray backend will record all those traces, and it will use the trace ID to stitch all the traces into a segment called a service map. Once the X-Ray has that trace, it will aggregate all the traces together into a dashboard for you to do some data analytics and help you identify bottlenecks as quickly as possible. We will set up our first X-Ray together later on. Okay, we now have AWS X-Ray to help identify and diagnose any bottlenecks in the system. Now let's put all of this into action on our very first version of the Pet Store. Here's the architecture of the Pet Store I'm about to show you. In the front end, we have a React.js powered by Amplify site. For the backend, we have a pet search API running on our container service, ECS. And behind that, there is a RDS Circle database and a S3 bucket to hold the images and other assets for us. It was pretty quick and easy for me to build, and I've also set up all of the performance testing tools we just spoke about. And here it is. We have lots of pets available for purchase already, and our users can browse those pets by category. All of this functionality is powered by our backend API, which is where we will focus our performance tests on. Remember, we're just about to launch the site, and the CEO is constantly asking those two questions. First, how many users we will be able to support on the launch day? 2, where are we likely to start seeing some bottlenecks if the site is more popular than we actually expected? In order to answer the first question, let's use the distributed load testing we created earlier and test it against 500 concurrent users. We'll create this test and we'll give it a name. Let's call it Pet Store API test. Because we are expecting 500 users by the day, so for this test, we will create 10 tasks in our load generator. Each task represents a load of 50 virtual users. So this would cover the 500 maximum users we are expecting to see on the launch day. We only have one region deployed. Let's use it. We will have the load ramp up slowly over 10 minutes, and then keep that amount of load for 5 minutes. I've already put the get pet by type endpoint in here. You can, of course, load a JMeter script. Let's hit run now. Okay, now that the testing is initiating, we will see some graphs for metrics at the bottom of this page. They are blank now, but they will fill in as the number of virtual users ramp up. While we're waiting, I'd like to draw your attention to some of the performance monitoring I deployed alongside this application, which can become very useful when we need to identify the bottlenecks. Firstly, I have 2 synthetic canaries deployed within CloudWatch Synthetics. The first one is for my pet list API, and as you can see, it's currently showing 100% uptime with no failures detected. Drilling in, you can also see some of the HTTP API response metadata, such as average response time, HTTP status code. The second canary is for my React.js website frontend. As you can see, it's also working at 100% right now. So we have a good baseline view of performance at the start of our test. Then I'd like to show you an X-ray of our API. Because I deployed the endpoint API as an Express.js application into ECS, there are 2 extra lines of code I need to instrument the application to use the X-ray SDK to collect the metrics. Secondly, in my infrastructure as code, I added the X-ray daemon as a sidecar container to send the metrics from ECS to the X-ray. This sample is written in AWS CDK. However, the idea is pretty much the same if you use other types of infrastructure as code tools. It was quite easy. I just had to copy-paste those sections into my projects. Now that I have the X-ray set up, it is collecting the traces on my behalf. Let's look at the performance on the dashboard. We have 3 callers to the API. First is the client, which I believe is the distributed load testing. Then we have the API canary. And there is also our front-end canary. Here we can also see the latency for each type of the caller, and on average, the latency is currently 6 milliseconds, and the database is contributing to 2 milliseconds to the processing time. Okay, now let's go back to distributed load testing, where we can see the metrics from our test are starting to come in. Let me accelerate this process. We can see the response time in the upper left here, and next to this, the number of virtual users, which is almost approaching 600 virtual users at this point of time. Then there's a request success rate in the bottom left, and we also have the failure rates in the bottom right. Now it seems like the testing has finished. Let's take a closer look at the data. At the starting of the test, we were seeing successful requests, but then after this point, 11:22, the success rate falls down to 0. Let's draw a matching line at 11:22 in virtual user chart as well. It's clear from the graph that when the number of concurrent requests is around 50, the system is working okay, but anything above that is causing the system to fail. Okay, so the next question for us is, what is causing this issue, or where is this bottleneck? Let's go back to the X-ray. Right, we see that the synthetic canary tests are reporting issues, and here is a red node. Let's zoom in this red node. Okay, this red node is our ECS API, and it seems to have stopped responding entirely. Let's go back to look at the service map for the API itself. This something really strange happens. The RDS database node is now gone. This suggests that our API hasn't been able to connect to the database at all within the last 5 minutes. Let's go to dashboard's database monitoring. Okay, here is the problem. The database connection number has exceeded the limitation. The limitation is 350, and we're requesting for 400 more. Let's also double check the other metrics to make sure there are no other issues. The CPU is at 52%, which appears to be normal. Memory is at 3 to 4%. So it seems like the database connection is the only issue in here. To resolve this, I'll next double check the code and maybe implement RDS proxy to fix this issue. As a conclusion, the system's current capacity is at 50 concurrent requests. If we were to push these limits, we would need to optimize the way we use database and decrease the connection count. Because the distributed load testing solution is serverless, we're not charged if the testing isn't running. Our total testing time was 20 minutes, and the cost was less than $1. Since the trace number is less than 10,000, the X-ray is free of charge. Of course, my pet store MVP minimum viable product is just a simple application created specifically for this demo. In our real life, for large, complicated systems, the performance testing can take more time and be more challenging, which may entail creating JMeter scripts from your browser. The key message to this is performance monitoring is critical for scalability, smooth operation, and providing your company with confidence in the software's efficacy. Great. Now, before I go away and work on fixing my application, let's take a look at the key takeaways from this session. First, performance monitoring and testing would bring confidence to the team when software accelerates. And there are methodologies we can leverage to make sure our end users are having good experience. Second, performance testing helps us answer questions about our system capacity limits. The tool we demonstrated here is the AWS Distributed Load Testing solution that is freely available. Thirdly, synthetic testing and X-ray are great tools to help monitoring and diagnosing performance issues. You can find all those tools in the AWS console under CloudWatch. Here are some of the useful resources I recommend checking out. First is a link to the AWS Distributed Load Testing that we used in the demo. Second is a guide on how to get started with CloudWatch Synthetics. And if you like some hands-on with those tools, then I highly recommend checking out the AWS Observability Workshop, which is full of modern application monitoring solutions. To continue your cloud journey, please visit skillbuilder.aws for more resources. Finally, we would love to hear from you about the project you are working on. Please do complete the session survey to help us improve events like this in the future. My name is Miranda Lee, and thanks for listening.